the first derivative can be used to determine whether a function is increasing or decreasing. And you are going to learn in this video how to find the intervals where the function is either increasing or decreasing. So I'll start with example 1. Find the interval on which f of x is increasing and the intervals on which it's decreasing. So the first step is determine the derivative or just the first derivative, which is f dash x. And we have already worked this out in the previous video, but this is just straightforward. So 6x squared minus 6x minus 12. It's a polynomial. It's easy to differentiate. And then step 2, we're going to find the critical points. Okay. Now, step 2, we need to find the critical points. And these are basically the points where the first derivative is equals to 0. So find the critical points. And these are the points where f dash x is equals to 0. Okay? So we can find this point by just write this properly. It's equal to 0. Okay, so we can find this point by equating this function to 0 and then solving for x. We have already done this in the previous video, and the values of x were x is equal to -1 and x is equals to 2. So these were calculated in the previous video. Okay, step 3, evaluate the derivative between or on either side of the critical points. So we have our critical points, but we need to investigate what's happening between them or on either side of these guys. So step 3, evaluate the derivative between or on either side of the critical points. So we want to find what's the derivative between and on either side of these guys here, which means we need to draw something like this. So basically these are values of x, by the way, and we have the critical points, values of x. We have x is equals to -1, so I just x -1 and x is equals to 2. Okay, but what I'm interested in is the signs of the first derivative. Okay, I'm interested in the signs of the first derivative. Okay, because I know that at x is equals to -1, the first derivative is 0. At x is equals to 2, the first derivative is 0. But what happens between them and on either side? So what I'm going to do is to choose what we call test points. So I'll just choose any point on the left. Okay, so any point on the left, any point here in between, and any point. And these points are called test points. For example, on the left, I can choose -2. And I may want to find out if I plug -2 into the first derivative, okay, here, what do I get? In fact, if you plug -2 there, you will end up with 24. So this will be equal to 24. How about if I plug in x equals to 0, because 0 is between -1 and 2. If I plug in f dash 0, and that will just be If you plug in 0, you'll end up with negative 12. Okay? How about if I plug in a number to the right of 2, for example, 3? And if you plug in 3, what do you end up with? If you plug in 3, you'll end up with 24. And you can try that in your calculator to check that. Okay? 24. Now, just remember that these points here, okay, these points here, they have a special name. Okay? They're just called test points. Okay? Because we are using them to test the signs of the first derivative. And here we can see that the first derivative is positive, here it's negative, and here it's positive. That's all we need to know. Okay? And for example, if the first derivative is positive, we know that the function is increasing. If it's negative, then we know that the function is decreasing. So that leads us to step 4. So step 4 will be find the intervals where f of x is increasing or decreasing. So find the intervals where f of x is increasing or decreasing. Okay? And we can go ahead and say, all right, so where will this function be increasing? Okay? Where is the first derivative greater than 0? And we know that the function will be increasing. Sorry. The function will be increasing when the first derivative is greater than 0. So, and we just need to inspect on the graph. Where is it greater than 0? And that will be when x is less than negative 1 and when x is greater than 2. Okay? And then, when is the function decreasing? And we know that a function is decreasing when the first derivative is less than 0. And we just need to investigate. Okay, here, when is the first derivative less than 0? When x is between negative 1 and 2. So, when x is between negative 1 and 2. And that's how you determine the intervals where the function is either increasing or decreasing. All right, let's look at example 2. Find the intervals on which this function is increasing and the intervals on which it's decreasing. So step 1, just like what we did previously, is to determine the first derivative. Determine the derivative. Now we have already done this in the previous video, and our first derivative was 6x over x squared minus 1 squared. So this was calculated in the previous video. Okay, step 2, find the critical points. So step 2, find the critical points. These points, just need to write it properly. And these are the points where the first derivative is equal to 0 or the first derivative does not exist, which means the vertical asymptotes. So these are the points where the first derivative is equal to 0 or the first derivative does not exist, which means we have the vertical asymptotes. Okay. We have already done this in the previous video. And in fact, we had our critical points as x is equal to 1, x is equal to -1, and x is equal to 0. So calculated in the previous video. Okay, so we have our critical points. What's the next? The next is to evaluate between or on either side of the critical points. So step 3 will be evaluate the derivative, value of the first derivative between or on either side of the critical points. Okay, so which means we need to draw a sign diagram. So something that looks like that, what we did previously. And this is for x values, and these x values are basically the we are going to mark on these x values the critical points. So we have 0, we have -1, and we have, sorry, -1 should be on the left. We have -1, and we have 1. So by the way, just remember that these guys here, they are asymptotes. Okay, and this is also an asymptote, which means the derivative does not exist at these points. And maybe I may just want to make this to the left, so somewhere there, so x. Now what I'm interested in is the sign of the first derivative, and to find the signs of the first derivative, I'm going to use test points. So I'll pick a test point here, test point here, test point here, and a test point there. Okay, so to the left of -1, I can pick -2. So okay, I need to find the value of that. So -2, if you plug -2 into the first derivative, what do you end up with? You'll end up with -4/3. So that will be -4/3. And you can check this on your calculator. In between here, plug in what's between there, -1/2. If you plug in -1/2 in the first derivative, what do you end up with? Okay, that's what you're plugging in. You end up with -16/3. And you can continue the same process. Here, plug in 1/2. That will be +16/3. Okay, and then plug in here 2, which will be 4/3. Now, let's now mark in the signs. So this is negative, that's negative, that's positive, and that's positive. Okay. Now we need to determine where this function is increasing or decreasing. So that leads us to step 4. So step 4, find the intervals where f of x is increasing or decreasing. Find the intervals where f of x is increasing or decreasing. And we know that f of x is increasing when when f dash x is greater than 0. So we know that this is increasing when f dash x is greater than 0. And just by inspecting on the graph, greater than 0, that will be between 0 and 1. When x is between 0 and 1, you cannot say when x is greater than 0 because we have an asymptote, which means the function does not exist there. So between 0 and 1, and when x is greater than 1. Okay. Decreasing when f dash x is less than 0. When is it less than 0? To the left of -1 and between -1 and 0. So that will be between -1 and 0, and when x is less than -1.